Okay, guys, we are going to start. We are working on the page 116. The topic is graph proportional relationships. Now, in the example 1, we have a graph and we need to recognize a proportional relationship. So, Tanya exercised for 30 minutes. She noted the calories burned at 3 times during her workout. So she wants to know now, using this information, how many calories she burned after 15 minutes of exercise. So she is working out. You can see it. You can see the information that in 10 minutes, she burns 95 calories. In 20 minutes, she burns 190 calories. And in 30 minutes, she burns 285 calories. So she wants to know what happened in the first 15 minutes. We can use a graph to display the data. This is a straight line. So because we are representing a proportional relationship, so the graph has to begin in the center, in the origin, 0 for x and 0 for y, 0, 0. And it has to be a straight line, a complete straight line. The relationship between exercise time is the x, the time in minutes, and y is the number of calories. So we need to use the graph to find the constant of proportionality. Do you remember about the constant of proportionality? K is equal y over x. So I'm going to show you the graph on the board and we are going to find the value we need. Okay. Remember about the minutes and the calories, okay? Because that's what we are going to use to solve the exercise. We have in here the graph. And we have counting by 5, 10, 15, 20, 25, and 30. These are the number of minutes for X. Now the calories is counted by 50. 50, 100, 150, 200, 250, and 300. Okay. Now I need to graph using the points. You can see that the graph is a straight line. It's like this. This is the graph you have. And we represent each point related the x with the y. When x is 5, when you have 5 minutes. Okay, but we are going to use it to 10. We are going to use it to 10 now because we are going to find something more later. When you have 10 minutes, they are 95 calories. Is going to be the point like in here. When you have 20 minutes, they are 190 calories. And when you have 30 minutes, you have 285 calories. Okay? That's what you have on the graph. But now, how are we going to obtain one value in here? We need to use 2 points from the graph. We have 3 in here because we have 3 intervals of time, 10 minutes, 20 minutes, and 30 minutes, but we only need to use the 2 of these points. We can use these 2, this, or we can use this. It's the same. We're going to obtain the same result. In this case, I think that I'm going to use the first one and the second one. I'm going to use this and this to show you different from the book. You have 10 for x. I'm going to write the coordinates, only the coordinates of the point, okay? The location, 10 for x, and y is 95. The next one, you have 20 for x, and you have 190 for y. 20 for x and 190 for y. Using these points, I need to find, you remember about this. K is equal y over x. Do you remember about this equation? We are using these equations since the last topic, okay? So this is what I'm going to do. We are going to divide the points of the y by the points of the x. But I need 2 points. I need this point and I need this. So what I need to do is to subtract the values for the y. I have 190 minus 95. And you have the other one, 20 minus 10. This is the value for the x. Now, remember x is on the bottom. 20 minus 10. K is 95. You subtract 190 minus 95 is 95. And 20 minus 10 is 10.
Good morning.
So, K is 9.5. This is the value for the K. This is the constant of proportionality. Remember, the constant of proportionality for this graph. This graph shows you a proportional relationship. So, what is the other equation we use? Now we know the constant. And we know that she exercised 15 minutes. She wants to know the calories burned in 15 minutes. So remember the equation, y equal k multiplied by x. This is the other equation we used. The number of calories, y, is equal k, that is 9.5. We already obtained 9.5, multiplied by x. What is x? The number of minutes. In this case, 15 minutes. And when we multiply this, we obtain 142.5 calories. This is what she wanted to obtain. What happened in the first 15 minutes, and she's going to burn 142.5 calories. Okay, this is the result for the exercise you have on the on the graph. Now we can go to the example 2. The graph shows a proportional relationship between the distance and the amount of time Mr. Brown drives. Okay, in the example 2, now we need a proportional relationship. We have a proportional relationship and we need to find the questions they are asking you. For example, I'm going to show it in the change in the 1, 2, 3, 4, and 5. 2, 3, 4, 5 until here. Now for the other one, I count 0, 55, 110, 165, 220, and 275. In the graph, I don't need these points. These points are going to change. They are going to be different, okay? So the first one I have is 0, comma, 0, 0 for x and 0 for y. And the other one is 1 for x and 55 for y. This is the coordinates. 1 for x, the first value is x, and the second value is y. And we have another point, I think. Okay. What does each of these points represent in this situation? The first one, 0, 0. Mr. Brown drives 0 miles in 0 hours. So the car is not moving because you move 0 miles in 0 hours, okay? The second one, 1 and 55. Mr. Brown moves 55 miles in 1 hour. Remember that x is representing the number of hours and y is the distance in miles. So, Mr. Brown drives 55 miles in 1 hour, and the next, the last 5 for x and 275 for y. What represents this point? That he is moving in 5 hours, he's moving 275 miles. So what is the constant of proportionality? We need to find the constant of proportionality. Find y coordinate when x is 1. I'm going to show you a trick in this exercise. For example, remember, we need 2 points to find the value of the constant of proportionality, right? To divide y over x, we need 2 values to subtract. We subtract y minus this and x minus the other x. But in this case, like x is 1, and you remember the formula that, okay, the formula states that k is equal y over x, but you already have that x is 1, your answer is not going to change. So I can divide 55 over 1, as the constant of proportionality is only this 55 over 1. So k is equal 55. This is my constant of proportionality. And later they ask you to write an equation that relates the distance and the time. What is my equation? Remember, y equal k multiplied by x. I already have the value for k. This is the equation I already used with you in the other classes. I have the value for k, it's 55, so I only replace. Y is equal 55 x. You can prove this. If you want to prove that the slope or the value for k is 55, you can prove it. You subtract the values. For example, you subtract 275 is the value for y, right? Minus 55 over 5 minus 1. This has to be equal k. And you need to obtain the same result, that is 55. You can prove it if you want, but you are going to obtain the same result. Okay. Now I only need to explain you the last part about the graph. Explain why each graph doesn't show a proportional relationship. Okay. I can erase this to explain you. Did you find the value to prove if it's the same or not? If we solve the subtraction, 275 minus 55 is 220. This divided by 4. This is 220 divided by 4. You obtain again 55. This is the constant k. If you subtract the point on y minus this other point of the y, x minus x again. But if you have, remember, if x is already 1, if x is already 1, you are going to divide only y over x. You obtain the same result. Okay, I'm going to erase this. I'm going to erase because you don't need these numbers. You only need the graph. I'm going to show you. You have the first graph and they are asking you if the graphs represent a proportional relationship or not. The first is a straight graph. So yes, it represents a proportional relationship because it starts in the origin in 0, 0 and is a completely straight line. So yes, it is a proportional relationship. The first one you have. We are on example 3, right? Recognize graph of proportional relationship. Now, the second one, it doesn't start in here. In the second one, you have something like this. And it's a straight line, but it doesn't begin on the origin. It doesn't start in 0, 0, 0. So it's not a proportional relationship. And what about the last graph? What about the last graph? We start like this. We have a curve and later it starts like this. It cannot be a proportional relationship. It starts in the beginning, 0, 0, but it's not a proportional relationship because it's not a straight line. It has to be completely straight to be a proportional relationship. The numbers I have in here, it doesn't matter, the values I have in here, but only to understand the difference. Not proportional because the graph passed to the origin, but it's not a straight line. So we can erase this part. Okay. What else we have in this example? Okay.
I don't understand what you do in the example two. With I don't understand. Only the todo al final entendí, mister, cuando multiplicó.
Okay.
Ya al principio ya no.
We're going to do it again, but only reading on your book because I already erased it. Example 2, interpret the graph of a proportional relationship. It is only asking you what means each of the insights they give you. For example, what does each of these points represent on the situation? You have the point 0, 0. 0 for x and 0 for y. But how are you going to know what this represents? Because x is the time in hours. You can see the graph. X is the time in hours. And y is the distance in miles. So you don't only have x and y. You have the time and you have the distance in miles. So when you have 0, 0, you don't have any hour and you don't have any distance. So this represents that Mr. Brown drives 0 miles in 0 hours. So the car is stopped, it's not moving. Now the second one, you have 1 and 55. This means that Mr. Brown drives 55 miles in 1 hour. Remember, X is representing the hour, so I have 1 hour. And 55 is representing the miles, so I have 55 miles in 1 hour. In the last one, you have 5, 275. This is representing that Mr. Brown drives 275 miles in 5 hours because 5 are the number of hours represented in the x-axis and 275 is the number of miles. So he is moving 275 miles in 5 hours. Now for the constant of proportionality and the In the equation, you remember about this, I think. The constant of proportionality is when you divide y over x. That's the constant of proportionality. So I don't know if this allow me to write. No. Okay. I was planning to write you something with the digital board, but I think it only works when I share the screen. Okay. So in the graph to represent in the example 3, they are only asking you to recognize the graph if they are a proportional relationship or not. For example, I can write other graphs for you, but it's going to be the same, okay? For example, this one, you are going to tell me if this is a proportional relationship or not. You have in this x and you have in this y. You can count, it doesn't matter. I'm not going to write the numbers because I don't need this one. But imagine that you have one line that passes like this. Is this going to be a proportional relationship? No, right?
No.
Because it doesn't start in the origin. When you have a proportional relationship represented in a graph, it has to pass through the origin. And for example, if I have this start in the origin, but it's going to be like this, can be this a proportional relationship? No, right? Because my proportional relationship has to be a straight line. It has to be completely straight. So this with this curve is not going to represent, we can erase this, it's not going to represent a proportional relationship. This is the shape, this is in the way that you are going to find the exercise when they represent a proportional relationship. Okay, and you divide y over x to obtain the value of, okay. Remember about the formula. I'm going to write you, this is the formula. And later we use the other formula that y is equal k multiplied by x. This is when we want to obtain something, like in the example 2, they are going to ask you about the distance in miles and the time in hours. Or the example 1 that she want to obtain the number of calories in a certain amount of time using the constant of proportionality. So I'm going to finish the class in here, guys. I hope that you are most clear now. You are clear, okay? So see you guys. Have a nice day and take care. See you.